Hyperbolas are very similar to ellipses in terms of the equation and all the stuff like the vertices and the minor axis, major axis, we just call something else, but they look a lot different. So I kind of made part of this graph for you, mostly because it was really hard to make the other part of the graph here.
Yes, I heard you on Chase on Friday.
I got to teach, and I'm recording.
So awesome.
It's not awesome. I know that Brandon too, because he was laughing about it.
Probably why.
Okay, so definition of ellipse is a set of all points in a plane so that the sum of the distance between two fixed points is always constant. And a hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from two fixed points called foci is constant. So again, we have these foci, which I called F1 and F2. The weird part about a hyperbola is that it's two pieces, and there are these asymptotes that kind of give you guidance here. And so just like with an ellipse, there are vertices that are A units away. So I'm going to say, I said vertex and vertex. If it was an ellipse, you have your distance from A, you have your B distance, and you connect it and you make that kind of ovalish shape. For a hyperbola, it's the difference between that, and so I kind of say it's kind of like you take the ellipse and you break it apart and fold it over, and it kind of ends up looking like two parabolas that go out like this. So one looks like this, and one goes down and looks like this, following the asymptotes. So if you know your center and you know your asymptotes, all you need are your vertices, and you can just use the vertices to follow the asymptotes. Instead of calling it the major axis and the minor axis, a little bit confusing, they call it the transverse axis. There needs to be an R in there. The transverse axis and the conjugate axis. Or you could call it the focal axis, because it's the axis that has the foci and the vertices on it, just like the major axis. Tricky thing about this is we can talk about A, B, and C again, but in a hyperbola, C is the biggest. So the relationship is that C squared equals A squared plus B squared. So you got to keep straight. In the ellipse, A is the biggest one. In a hyperbola, C is the biggest one. So I left lots of blanks for you to fill in on this, right? That's exciting. Okay, so an asymptote, you know what that is. A line the hyperbola approaches but never touches. The distance from the center to a vertex, just like an ellipse, is going to be A units. So that means the length of the transverse axis, just like the major axis, is 2A. So that's in here. The transverse axis is 2A. The distance from the center to a focus, just like an ellipse, is C units. And the conjugate axis, aka the minor axis of an ellipse, is 2B units. Oh yeah, and I already wrote C squared equals A squared plus B squared. Again, try not to be overwhelmed by all these formulas. The idea is if you understand the basics of it, you're going to be able to write these equations and graph them, which is really all I'm asking you to do from here. But I left all these blanks for us to write in. Isn't that exciting? I'm skipping the center at 0, 0 on this one, but if it was 0, 0, just like all the other ones, we could just leave the H and K out. Just like everything else, there are two forms of the equation. If the major axis, or the transverse axis, or where the focus and vertices are, is horizontal, that means it's going to look like this. Where am I going to fit that in? I'm just going to draw it like this. That means it's going to go like this. That would be horizontal. Or if it was vertical, that means it's going to look like this, right? So the equations change depending on which way it's going. But very similar to an ellipse here, all right? So this one's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. So notice that that equation looks just like the equation for an ellipse, except for its subtraction, and that comes from from the fact the definition is the difference of those two fixed points. Something else to notice is remember that A isn't always the biggest number, but A is the positive one if it's going horizontal, which means if it's going vertical, it's just going to be Y is going to be the positive one. So that would be Y minus K squared over A squared minus X minus H squared over B squared. The vertices are A units from the center. So if you're going horizontal, then you are going to add A to H. So your vertices are going to be H plus or minus A, comma K. And your foci are C units from the center. So again, going horizontally from the center would be H plus or minus C, comma K. If you're going vertically, you're moving up and down. So that's why you're adding and subtracting to K instead of H. So that becomes H, comma K plus or minus A for the vertices, and H, comma K plus or minus C. And again, you're welcome to try to memorize all of these, or just think through it. The covertices, we're going to talk about in a minute. Why would you even need to graph the covertices? Because the covertices are this axis, but I'm going to show you a shortcut here of why that might be a good thing. In an ellipse, those are called the minor axis lengths. So a little tricky because covertices are going to be going the opposite direction. So going horizontally, covertices would be going B units this way. So that would be H, comma K plus or minus B. And this one would be H plus or minus B, comma K. So that's true. And the asymptotes are those lines that are going to go through the center. And it looks a little scary, but it's just slope-intercept form going through the center with a slope. So on this one, it's Y minus K equals plus or minus B over A times X minus H. And on this one, it just changes to A over B. So it's plus or minus A over B, comma X minus H. That's just point slope form. There's a plus or minus because there's one positive slope, there's one negative slope. H and K are the center. And the reason the slope switches is going horizontally, right? B is going up this way and A is going this way. So if you went up and over as your slope, that's why it's B over A. On this one, A is going up and down, so that's why it's A over B. So again, you can kind of think through that instead of feeling like you have to memorize it. If it was at 0, 0, if you wanted to write that, that would just be X squared over A squared minus Y squared over B squared equals 1. Or Y squared over A squared minus X squared over B squared equals 1. If there's no adding and subtracting, then you know it is at the center. What do I want you to be able to do from this? I want you to be able to graph it. I want you to be able to maybe label or tell me the vertices and the foci if needed. And I want you to be able to put it in standard form by completing the square like we did before. So those are the kind of examples we're going to go through. That's pretty much what I expect you to be able to do with all the conic sections, knowing this, okay? Just like an ellipse, we can talk about the eccentricity. It's still the same formula. It's still C over A. In an ellipse, remember that it's always between 0 and 1 because A is always bigger than C. But in a hyperbola, C is always the biggest value, so it's always going to be bigger than 1. But if you get a really big number, we can say that the branches, they call them the branches, I think they call them the parabolas, they're not really parabolas, but they call them the branches of the hyperbola, are nearly flat. And if it's really close to 1, like 1 is the smallest that it can, well, it can never be 1, it can be really close to 1, then it's going to be more pointed. That's pretty vague explanations there, right? And we'll talk about that as we graph them. All right. Let's look at some awesome ones here. I only have 2 examples if that makes you feel any better. Oh, I mean one on the back. Why don't I only have two on mine. I must have added an extra one for you.
You have to do it every time.
No boo. I have 2 days of notes. The last time I taught this chapter for all of these sections, but I've condensed them down for you into 1 day of notes. So that must be what number 3 is, but that's okay. Look how nice, it's in the right form. Find the center, the vertices, the foci, and the equation for the asymptotes for the hyperbola, then sketch the graph. Which way is this one going to go? Up and down, left and right? It's tricky, right? Because we're so used to ellipses and we think that the biggest one has to be A. But remember that in a hyperbola, the A is one that's not negative. So A is this. So if Y has A under it, it has to go up and down. All right, so you got to kind of keep that straight between ellipses and hyperbola. So that means that my center, be really careful. It's really easy to say the center is -6, 1, but remember it's X is with H, Y is with K. So the center is really 1, -6. Right? If you do it backwards, then you do the whole graph backwards. That was a lot. We know that A is going to equal 4 and B is going to equal 5. So if I want to find my vertices, and I know that it's going up and down, which am I adding A to? Am I adding 4 to 1 or am I adding 4 to -6? If my center is at 1, 1, 2, 3, 4, 5, 6. Here's my center, and I know that the branches are going to go up and down. That's going to be A units away, right? So if it helps you, it always helps me to just think about it. Oh, I'm going to add A and subtract A from the center going up and down. That means I'm going to add it to K. Does that make sense? So if you were supposed to list the vertices, you could just graph them first and then tell me the points. But that means I'm going to add and subtract 4 to -6. So that's going to be -6 plus or minus 4. So -6 plus 4 would be -2. And -6 minus 4 would be -10. Agree with that? So up 4, 1, 2, 3, 4. That's a vertice. Down 1, 2, 3, 4. If this were an ellipse, that would be our major axis. Like we would connect that. But a hyperbola is like flipping that over. Does that make sense what I'm saying when I say that? Like if this is your ellipse, it's like we're finding the center and we're taking each branch and flipping it out. You know what I'm saying? Like that's how I think about it, of why ellipses and hyperbolas are so close together. Ellipses are the sum and the hyperbolas are the difference, and we take and separate it. They also asked me for the foci. A lot of times the foci are going to be not very pretty numbers because you're going to get a radical. And I think that's going to happen on this one. Remember that C is the biggest one, so if we're going to try to find the foci here, we're going to say that C squared equals A squared plus B squared, which is 16 plus 25, which is 41. Is that true? So square root of 41. The good news is you don't have to graph the foci in order to graph the hyperbola or the ellipse. But if they ask you to write it out, you just need to know, just like the vertices, you're going to add that to the y value. So you can just say that that's -6 plus or minus the square root of 41. And I would just leave it like that, because otherwise you just have to give decimal. Whereas the vertices, you'd actually give me the two numbers. Okay, I want to show you the shortcut here for graphing these, and then we'll talk about the equations for the asymptotes. So if we had the asymptotes, do you agree that that would kind of help us know how wide to make our, what's it called? Branches of the hyperbola. So this is where B comes into play. So just like B on an ellipse is the minor axis, on this one, B is going to be the axis that goes the opposite way. So if B is 5 from the center, I know I can go over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And again, if that was an ellipse, Kind of a weird ellipse because we've made it the wrong way, but that's what you would connect. The asymptotes are always either A over B or B over A units, which means instead of graphing B, you could have just figured out your asymptotes always go through the center. So one thing you could have done is you could have just done your slope, which in this case is going to be A over B, and that would have been a point on your asymptote. But here's kind of a cool thing. If you look in your book, you're going to see this little square that they always draw, this rectangle. If you connected your vertices to your co-vertices with just little dotted lines here, you agree that it kind of makes, well, not kind of, like it makes a rectangle? Get dotted lines on here. Your asymptotes will always go through the center, and they will always go through the corners of that rectangle, which means you don't have to really think about the asymptotes so much as long as you graph the A and the B right, because my asymptotes are going to be up A over B, which is always going to be right there, or if I went down A units over B units, it would be right there. So my asymptote with the positive slope is going to go this way, and with the negative slope, it's still going to be up A, but I'm going to go back B, or down A over B is going to be through this one. And that's a whole lot of dotted lines on our paper, but you'll see in your book they make that rectangle every time, because now you can use that to graph your branches. Here's my vertices, you got to remember which one it is, and it's just going to kind of follow those asymptotes, and I'm not going to be that picky about that. So really the hyperbola is just the two branches, but if you didn't have the asymptotes to kind of guide you, then you end up having to pick a lot of points, and it's not that much fun to graph. But the little rectangle trick, or knowing that you just go up A over B, is a nice way to do it. It says find the equations for the asymptotes. I don't know that I'm really going to ask you to do that, but it's just y minus k, so it's just going to be y plus 6 equals plus or minus, if we're going up first, that's up A over B, so our slope is, oh, I guess not A over B, plus or minus 4/5 times x minus 1. And if I ask you to write the equation of the asymptotes, you don't have to work that out because we already graphed it, right? Like we would only need to work it out if we didn't know how to graph it otherwise. Hyperbolas are my least favorite. In your book it says hyperbolas are the least known about. What does it say? That was really funny. The hyperbola is the least known conic section, yet it is used in astronomy, optics, and navigation. Probably the least known about because it's not so much fun to do. Okay, let's put it in standard form. I mean, just, yeah. Sketch the graph. So just like all the other ones, we have to complete the square to make this look right. There's no other x in this problem, right? So that means I don't have to complete the square for the x, so I'm just going to leave the x right there. And then for the y, I'm going to go ahead and factor out the negative 9 and make that y squared minus 4y. Leave the space to complete the square. If there was an x to the first power, you'd have to complete the square for it also. And I'm going to go ahead and add 72 to the other side. If you did the ellipse homework from 8-2, it's very similar. The only difference is we're going to end up with a subtraction sign in the middle instead of an addition sign. So to complete the square, half of negative 4 is negative 2 squared, which is 4. But remember what you put on the other side. You have to multiply 4 times that negative 9. So you're really putting a negative 36 over here. And then that would just become y minus 2 squared. And then that would be 36. And then remember that that side has to equal 1. So we divide everything by 36. And we get x squared over 36 minus y minus 2 squared over 4 equals 1. And again, how do I know which one's A and B? It's by which one's positive, not necessarily which one's bigger. So since my x squared is positive and my y has a negative in front of it, that's how I know A is 6 and B is 2. Questions on how I got that? So A is 6, B is 2. Which way is this one going to have the branches go? Side to side? Side to side because A is first. What's my center of this? 0, 2, because there's nothing over here. And so if it just says sketch the graph, you don't have to list out the vertices and all that stuff, but you do need to know how to get those asymptotes. And so that's where the little shortcut I think is helpful. Center, 0, 2. You got to know which way to make your vertices. It's going right to left. So we're going to go 6 units each way, right? 1, 2, 3, 4, 5, 6. We end up putting a lot of dots on here, so it helps me to label that as a vertice, so I remember that's where my branches are starting. And if you don't want to make the rectangle, you don't have to, but you need to know your asymptotes. Either the ratio you need to know is B over A on these, or you can just think about the slope. If you go up first and then over, B is going up and down on this one. I use the rectangle because I know B units are going the other way, so I'm going to go up 2 and down 2. I went down 4. It's really hard to talk and write sometimes, you know. They are very hard. And then I know that my asymptotes are going to cut right through the center, through the corners of that rectangle, right? This one's going to be a lot smaller than our last one. So then starting here, I'm just going to follow my asymptotes. Oh, I totally didn't follow that one very well. I'm not going to be super judgy on your graphs here as long as the points are in the right spot. Your asymptotes are going to the right spots. Okay? All right, I think I put the last one there just to show you sometimes crazy stuff happens. So get a head start. Write this in standard form, which means get your x's together, get your y's together. See if I wrote this right. See if something crazy occurs. And notice I didn't say you have to graph this one. There's so much room on my y's, I'm not much room on my x's. I just added a 128 over and didn't even pay attention that there was a 1 there. Did you get this? Are you on your way to getting this?
Yeah.
What feels wrong about this? That 30 equals 1, right? And you have to have it equal 1 in order to have it in standard form. And so the question is, what happens? Like, what do I do with that 4 and that 9? But then it's not going to equal 1. Hyperbola. Not hyperbole. Don't get confused. Hyperboles English. Hyperbola. Like what would, like this is standard form, but it looks really weird. So my question is, what is A?
Word 2. Or no, A. Is it?
Is this the same as that?
You're saying y to the subs. What did you write?
X minus 2 squared divided by 1/4.
Oh, what? Okay, I thought it was y. Oh, I did too.
Here's my y. I don't make y's like that. Is that the same as this?
I guess. Yes.
That's weird, right?
Write it like that.
Either way would be okay. If you were going to graph it, you would need to know that A, like, think about if you graph that. That's why this is not really good to graph. You would go 1/4 of a unit left and right from your center, and 1/9 of a unit up and down. I mean, maybe you'd want to make your graph go by, like, tenths or something. I don't know. Would not be that fun to graph. But I just wanted to show you that sometimes if A and B are a fraction like this, that you just have to think about dividing by a fraction is the same as multiplying by this, and so that just makes those fractions. So is that going to show up really that much? I don't think so. But I just want to show you that it could happen. Right? This is your homework. Sometimes I feel like I just don't even know what I'm doing with my life.
That's why I put it.
3 to 6, you're just supposed to find the vertices and the foci. You don't have to graph those. 7 through 11, you're matching the graph with the equation, which should be pretty easy based on the center. And then 15, 21, and 22, you are graphing. It says graph with your grapher, but I want you to graph those by hand. Tomorrow we'll use the grapher, and that's what your book calls it. Graph using a function grapher, it says. Graphing. Oh, 50 says graph also. So I'll give you graph paper if you want, but honestly, sometimes I think these are easier to graph on your own paper because you can make the points, the axis go where you want. But I have graph paper if you want it, and you do actually have some time to work on this or your worksheet that